So I'm getting a signal we are good to go. Welcome to this Bosch Manufacturing Solutions live stream right here from the CES in Las Vegas, and you can catch a glimpse of the bustling activities behind me. We are here at the Bosch booth in Las Vegas and are, as Bosch Manufacturing Solutions, looking back at 2 very exciting days already at this wonderful show. Lots of context, much relevant, interesting input, and a lot of good leads we will be taking back home after the show. Now, I would like to talk about what drives us currently, what is coming from our customers and from the market. Then this is a clear demand to us as machinery builder for more adaptive, more cost-efficient machinery, engineered and delivered at ever faster speeds. And therefore, I would like to talk about how we answer to these challenges with our advances in software-defined manufacturing and how we make you more cost competitive with digital engineering, smart processes, and intelligent production solutions. Now, adaptive, faster, more cost-efficient, these are requirements that are also highly relevant to electronics and battery manufacturing. What we are seeing is variance in sizes, in shape, and even in process sequences, especially in power electronics, that demand adaptable and flexible machinery. We are also seeing pressure on time to market, especially for our Asian customers that are regularly asking for lead times of less than 6 months, even for complex pieces of machinery. And last but not least, we believe reliable performance is the key to bringing down TCO. Machinery needs to perform robustly, no matter where you operate the machinery, no matter how the supply chain looks like, and you need to minimize downtime and you need to find answers to that. Now, to answer that and to explain how we react to these challenges and how we are driving forward, I have divided this talk into 3 parts. The first part is about our manufacturing processes and their versatility. The second part is how we bring down engineering lead time through digital engineering. And the last part is about how our digital solutions help you to operate equipment at the highest possible performance. Before I go there, let me introduce to you who we are. Not all of you may know this. We are Bosch Manufacturing Solutions, or BMG. We are a global industrialization partner and turnkey special machinery provider. We have more than 30 years of experience in the industry under our belt, and over our history have delivered more than 4,000 assembly and testing systems, and on top of that, more than 10,000 smaller and services projects. We can tailor our automation level to your needs, be that manual, be that semi-automatic, and be that even, of course, fully automated solutions. We digitize in a consequent way. We have a digital planning process. We have digital engineering tools that I will introduce later on. And we provide digital intelligence solutions for the operations of our equipment to you. We are close to you with more than 17 locations around the globe, have a vast full liner portfolio, and about 1,900 bright associates who work for us. Our turnover almost hit the 700 million euro mark as of 2024. Ladies and gentlemen, our portfolio, our power is based on 4 pillars. The first pillar coming from the left-hand side is the advanced manufacturing processes and technologies know-how, where we really have deep understanding. We have strong digital engineering capabilities that we also provide as consulting services. We provide digital intelligence solutions to you, as mentioned, and of course, we also top that up with services worldwide along the entire life cycle of the machinery. Now, as promised, first part of my talk, what are we doing in terms of manufacturing processes and technologies? In the context of electronics and battery manufacturing, a lot of processes are relevant, and not all of them are on the slide, and I will certainly not read through all of them. The point here is that we master them. We master joining processes, we master handling processes, we master measurement and testing processes, and of course, further relevant processes like flex foil handling or plasma cleaning, should you need them. And I will deep dive in a couple of examples here to show the versatility of our processes. First example is dispensing. We are having quite a bit of experience in dispensing with more than 200 units in the field, proven reliability, and yes, also in dispensing we can deal with variants. We can deal with sizes ranging from a 100 by 100 millimeters to 600 by 600 millimeters. We can deal with different mass requirements. We can dispense milligrams up to kilograms. We can provide outstanding precision and repeatability to you. And should you need that, speeds in excess of 1.5 meters per second to speed up your dispensing processes. On top of that, we are able to provide quality checks, optical quality checks, inline, on the fly, that would happen immediately after the dispensing processes without any need for investments into further separate equipment. Second example is laser welding. Laser welding goes a long way back at BMG. We have lots of experience in lasers, also in laser machining, but here I'm going to talk about laser welding. And yes, once more, we can deal with variety. Our optics expertise allows to deal with flat geometries, 2D geometries, but also non-flat 3D geometries. And we can deal with different material combinations, be that copper-copper, copper-steel, copper-aluminum, steel-steel, you name it. It's talking about lasers. It gets even more interesting, and especially because we are here in the context of software-defined manufacturing, when you bring together adjustable processes, software-adjustable processes with machine learning capabilities. And I'm going to illustrate this here with an example coming from laser machining, where we have a laser process. You can see that maybe in the upper right-hand corner, if you're able to zoom into the slide, where we machine first, then collect data after the surface has been machined, and feed that data into a model that then provides parameters for the next machining step. And we have a number of unique selling points here. The models that are running in the background are not any empirical model. These models are based on physics and a true physical understanding of the process. And because it is so, we can fine-tune the model to your particular setup with a minimum effort. So we know where the uncertainties are, and we can minimize the sampling effort to provide accurate models to this process in its individual machinery. Once trained, the operation is fully automated, and even self-calibration is happening once the machine is detecting deviations are there. With this in place, you're going to get quite a number of benefits. There's an optimization of process yield. There's additional robustness because you have the model in the background, and of course you would not need any experts to operate the machine or to calibrate the machine, because the machine is doing that itself. The next chapter, ladies and gentlemen, digital engineering. So I mentioned I would like to illustrate how digital engineering helps us to bring down engineering lead time and then also machinery lead time altogether. In digital engineering, as we are engineering at Bosch Manufacturing Solutions and build equipment for the physical world, we are also taking a journey in the virtual world. And in this virtual journey, the general simple idea is to use the capabilities of the digital twin and of simulations to learn as early as possible and to improve as early and at lowest cost possible our engineering work. And how we do this, I will illustrate with two examples, simulation examples over the next two slides. Okay, first example is what we call the value stream simulation. This value stream simulation is happening very early in the engineering phase. It's happening on line level, and it's happening long before we have any detailed design of the machinery. This is the stage where we look at different concepts and compare them and try to find out what is the optimum concept that fits your particular needs. So what we are doing there is we are running long-term simulation of how material flow is happening through that particular concept and what kind of performance metrics are being achieved. And the simulations we run are true long-term simulations that amount to the equivalent of months and even years of real production. And in doing so, We are able to robustly check the line logic, checking the line performance like throughput time, minimize the investment into physical assets like workpiece carriers or AMRs, and even check inter-machine dependencies. And you may have them in electronics manufacturing. For instance, if you're looking at dispensing processes, a dispensed adhesive will harden after a certain amount of time, and you want to make sure that your part is processed in due course to avoid this happening. So such requirements, we are able to check that well ahead of time. We're also able to remove any weaknesses, obviously bottlenecks we are looking at closely, and the results are very obvious. You're going to get lean, optimized layouts, reduced investments, robust interlogistics, and we are all set up and have laid the foundation for a fast ramp up later on. Second example is virtual commissioning. Now this is happening a little later and it's happening at a deeper level. Here we are on machine level, and still we do not yet have a physical machine. Yeah, maybe a detailed design, but the physical machine is not there. And what we are doing at this stage is we are striving to have the PLC code ready and to run this PLC code in a simulation with our multidimensional model of the machine. And it's not only about mechanics. We are able to check kinematics, robotic functions. We are able to run special modes like changeover sequences or calibration. And we are, last but not least, able to check also the communication of the machinery with the environment at the customer, a point that frequently has been hard to do in real life. Benefits. For us, this is really a game changer. We see shortened commissioning times by up to 2 months. We see a strong reduction in failure costs that otherwise would happen in the commissioning and ramp-up phase by up to 30%. And we can make sure that our machinery is well behaved no matter what comes along. So we are able to stress test the machinery for quite a number of unusual and infrequent situations. And again, last but not least, we are ready for life cycle optimizations. So should you require any retrofits during the product's lifetime later on, we have the models ready, we can run the software, and we can prepare these retrofits with a high degree of maturity well in advance to make sure that once we implement a retrofit into your line, we can do that reliably, really with the minimum amount of downtime. In my last chapter today, I would like to talk about our portfolio of digital and intelligent solutions. Now, this is a little bit of a diagram in terms of architecture. Our intelligent solutions, they summed up in what we call our intelligent production suite. They sit between the field level that you can see below and the plant operating system like the plant manufacturing execution system. And they come in 3 baskets. With the left-hand basket, we provide system connectivity, mainly to the controllers, but also to any other partner you want to connect to. With the middle basket that we name Intelligent Edge, we are targeting experts. We are targeting people who really would like to understand what's happening inside the machine, would like to understand process metrics, would maybe like to set up closed loop control for machinery in production. With the right-hand basket that we call line and shop floor solutions, we are targeting operations personnel, planners, setters, operators, to help them with maintenance, to help them with operator assistance and many other goodies that we can provide. Very briefly, we have a much larger portfolio, but I would like to deep dive a little bit within the remaining amount of time into 4 examples. On the left-hand side, 2 examples from the Intelligent Edge. First example is what we call process monitoring. This is a tool where experts can zoom into process metrics, compare different situations, really get an in-depth understanding of what is happening, for instance, with time series data inside of the machine. This helps a lot with root cause analysis, makes that faster, and also helps, especially in the commissioning and ramp-up phase, bringing down the lead time. The second example is, of course, we are using AI also here. We have an AI-based anomaly detection that we train on time series data, and without any further hard coding from your side, this algorithm is able to detect anomalies so that you are able to detect anything that goes awry very early on before risks grow to a more unmanageable amount. We are also able to issue notifications so that you can trigger your respective target group automatically from those detected deviations. On the right-hand side, in terms of line and shop floor solutions, 2 or 3 examples. First example is what we call the KPI view. This is a very simple yet successful solution where you can bring your visualization, you can bring your KPIs and integrate that into the surface. It gives you a real-time understanding of what's happening on your shop floor with the real-time KPIs and the traffic lights, systematic. And in terms of architecture, it also operates as a middleware between the machinery and any plant data platform should you have it. Benefits here, high degree of transparency, high acceptance and quick reaction capability to things happening on the shop floor. Last but not least, a combination of 2 solutions that we call the maintenance ticket system and the experience share system. Together, they are a powerful solution to address unplanned machine downtime. The maintenance ticket system is a system where tickets to target groups can be issued automatically. This is highly configurable, where you can determine the workflows, determine what channels you want to use, how you want to set up reminders, and many, many other obvious parameters to really tailor this to your needs, so that the people you want to reach are getting a ticket automatically. But this is further substantiated by the experience share system. And the experience share system is a system where people can collect and document the experience they have made in and around a certain trigger point, for instance, an error message. And this allows you in a follow situation where an error occurs again, that the people addressing this error can profit from the experience documented from the ones that handled the same error before. The benefits here: shortened mean time to repair, shortened downtime, systematic problem solving, and also it helps a lot with fostering your know-how buildup. Ladies and gentlemen, I would like to come to the end of my talk today. I started out with the challenges that we, and I assume you, are also facing with bringing in more adaptive, more cost-efficient machinery with lead times that are extremely fast. And our answer as Bosch Manufacturing Solutions, as BMG, is triple. We have versatile manufacturing processes and deep systems know-how. We provide a closed group of solutions for high-performance, data-driven manufacturing. With this, I would like to thank you, first of all, for being with me, joining us today here at the CES. Should you be close, you're welcome to visit us at any point in time. We are here at booth 16203. Should you be more remote, there are other channels that you can use to join us. Some of them are on the slide. In particular, the QR code will take you directly to us. I hope to be in contact with you very soon. I hope that this talk was interesting to you. And with that, I would like to close for today. Thank you again for being with us, and goodbye.